Okay, friends, so we're going to take a look at some examples of the nth term test for divergence. So we're going to just use this test to determine if the following either diverge or the test is inconclusive. So I've got these two examples here, so you can pause the video if you want to read them over, but I'm just going to jump right into them. Okay, so I've got e to the n over e to the n plus n. All right, so what does the nth term test for divergence say? So it says that a series diverges if the limit as n approaches infinity for the sequence either fails to exist or is different from 0. Okay, so I want to point out that this only states whether something diverges. It has nothing to say about convergence, okay? So all we're being asked here is to determine whether this diverges or not. Okay, so we're going to go ahead and take the limit of this sequence. And I notice right away that this gives me infinity over infinity, so I can use our old pal L'Hopital's rule. So if I take the derivative of the top and bottom, so now this becomes e to the n over e to the n plus 1. Okay, so that's still infinity over infinity. So now I'm going to have, take the derivative one more time. So I get e to the n over e to the n. Well, that actually just equals 1, right? So that equals 1. So remember, what does the test say? It says that it has to equal 0. So since my limit was 1, that implies that the series diverges. So that's the way that you use that test. Okay, so let's compare that to this next example. So I've got n over n squared plus 7, and I'll do the same thing. So I've got n over n squared plus 7. Okay, so what I could do here is I could also just divide everything by n squared. So let's just do that. So this will give me 1 over n over 1 plus 7 over n squared. Okay, so that gives me 0 and 0. So when I take the limit, this becomes 0 over 1, so this just equals 0. Okay, so again, all this says is that the series will diverge if the limit fails to exist or is different from 0. So I got that this is 0. That doesn't mean that we have convergence. This just means that the test is inconclusive. So if I were using this test, I'm just using this really as a quick way to figure out, does it diverge? Because if you know it diverges, right, you're done. But now, since it's inconclusive, I'm going to have to use other tools in my toolkit to figure out what to do next. Okay, and so that's it for those. So short and sweet. So hopefully that just gives you a little bit of a better idea of how to use that test. I'll catch you guys in the next video.